Alright, today we're going to look at right triangle trigonometry. And you'll remember that in a right triangle we always call the longest side of the right triangle the hypotenuse. Now the other two sides, which we call legs, are labeled either the opposite side or the adjacent side. And so you say, well, which is which? Well, this depends on the acute angle that I choose to look from. So our triangle must have a right angle, that's a given. So we then choose to look at one of the two other angles. So I'm going to look from this angle right here, which I have labeled theta. That's a Greek. It's a letter of the Greek alphabet that is typically used to designate angles. And so if I choose to look from this acute angle, then this side across from it is called the opposite, and the side beside it, the leg beside it, is called the adjacent side. So I stress that the opposite and the adjacent side are determined by the acute angle that I choose to look from. And then from there, I can choose to look at the ratio of various sides. And we have three particular ratios that we typically look at. The first one is the sine ratio, which is a measure of the opposite side length divided by the hypotenuse. Cosine is the adjacent side length divided by the hypotenuse. And the tangent ratio is a measure of the opposite side length divided by the adjacent side length. Now these ratios are commonly used, and we need a way to remember what sides each of these ratios relates to. So we have an acronym for this, and for sine, which is opposite over hypotenuse, and cosine, which is adjacent over hypotenuse, and tangent, which is the opposite length over the adjacent length. This produces an acronym that we call Sohcahtoa, which helps us to remember which ratio relates with which ratio of sides. Alright, what I have here are two triangles which are congruent at the moment, and both are right triangles, and the acute angle down here I have drawn to be 30 degrees. So if I have asked you to draw a 90-degree triangle with a 30-degree acute angle, which would therefore make this angle 60 degrees, you might draw this triangle precisely. However, you might also draw a triangle that was a little bit bigger, because in expanding this I still have an angle down here which is 30 degrees. This is still 90, and this is still 60. Now you remember that triangles which have the same angles are called similar triangles. Okay, they have the same angles. And the other thing we know about similar triangles is that the ratio of corresponding sides is equal. So in my first triangle, if I were to measure, for example, the opposite length side, the opposite from 30, and the hypotenuse, that should mean that I would get the same ratio as if I measured the opposite side in this triangle and divided it by the hypotenuse. Well, you remember that the ratio of opposite to hypotenuse from Sohcahtoa is the sine ratio. So what I'm saying is that the sine ratio, given a 30-degree angle that I'm looking from, the ratio of opposite to hypotenuse should be the same. Well, we don't actually have to draw triangles, measure sides, and divide corresponding sides to figure out what the ratio is for a given angle. All we need to do is go to our calculator and enter sine 30. Now, in working with your calculator, the first thing you need to be aware of is that you need to be operating in degree mode. So if you go to your mode button right there, you want to make sure that the third line down, that the degree designation is highlighted. Alright, So let's go off to a blank screen. And so what we want to know is we want to know what is the opposite to hypotenuse ratio, which is the sine ratio. The next thing we'll type in is the angle we're measuring from is 30 degrees, so we'll put the 30 in there. And if we press enter, it's telling us that the ratio of the two sides is 0.5. In other words, the opposite side is half the length of the hypotenuse if the angle from which we're measuring is 30 degrees. And similarly, this works if I were to measure the adjacent length to the hypotenuse. Now what would change would be the fact that that's a different ratio. The adjacent divided by the hypotenuse ratio is the cosine ratio, abbreviated COS. So the cosine of 30 degrees, from my calculator, I would type 30, or cos 30, and that would tell me that the ratio is 0.866. 87 rounded off. In other words, the adjacent length is 87% of what the hypotenuse is. Finally, for tangent, the tangent of 30, the tangent ratio is a measure of the opposite length to the adjacent length. If I look back at my triangle, I can see that my opposite length looks smaller than my adjacent length. So if I take a smaller length divided by a larger length, I should expect to get an answer that's less than 1. Alright, and if I go to my calculator and type tangent 30, I'm finding that the opposite to adjacent ratio is 0.58. Alright, I have a right triangle here with So we begin by looking for theta. Theta is in this position, which means that the side straight across from it is called the opposite side. The 5 is the hypotenuse, it's the longest side of the right triangle, and the leg beside theta is the adjacent side. So all I'm being asked for here is the ratio of sine, cosine, and tangent. So all I need is the opposite length, 4, divided by the hypotenuse, 5. I could leave it like that, or I could write 0.8. The 0.8 would mean that the opposite side is 80% the length of the hypotenuse. The adjacent is 3 divided by hypotenuse 5, which is 0.6 as a decimal. In other words, the adjacent side is 60% the length of the 5, the hypotenuse. And the tangent ratio is 4 divided by an adjacent length of 3, which is 1.3 repeating. In other words, the opposite length is 133% the size of the adjacent side. And that's all that we're being asked for at the moment. But now let's take it one step further. What if we were asked to calculate, to find the angle theta in degrees? And let's do that to 2 decimal places. Now on my calculator, in the last example, we were given the angle. So if we knew what the angle was, we could use our calculator to enter the sine of the angle to get a ratio of 0.8. What we want in this case is the exact reverse. We know the ratio. We want to know what ratio of opposite to hypotenuse gives us this particular angle. So there is a way you can reverse the idea or the calculation with your calculator. If we're told that the sine of theta is 4 over 5, we can get the angle by doing the inverse button on the calculator, which is denoted as follows: sine -1 So if I go over to my calculator, what I need to type in is shift, second function, sine, inverse, 4 divided by 5. So I want to reverse the ratio, and it's telling me the angle is 53.13 degrees. Theta is 53.13 degrees. Be sure you put your degree sign in. That's like putting in your units. Now you might be wondering, well, why did I decide to work with sine? I also knew the cosine ratio and the sine and the tangent ratio. Well, you could have. You could have used any of the three. So let's just confirm that that would actually work. If I use my cosine ratio from above, which was 3 over 5, the cosine ratio of some angle is 3 over 5. I can go in reverse, again, by entering inverse cosine of 3 over 5. And obviously I should get the same answer because I'm talking about the same angle I was above. Shift cosine 3 divided by 5, again 53 degrees. And just for the record, let's do it for tangent as well. We knew the tangent was 4 over 3, so if I wanted to get the angle using tangent, I would enter inverse tangent 4 over 3. Second function tangent 4 divided by 3, and again 53.13 degrees. Alright, let's use what we've talked about to solve 3 problems, and these 3 problems represent the 3 different types of trigonometry calculations you'll typically run into. So first of all, how do you know it's potentially a trigonometry question to begin with? Well, you'd be dealing with a right triangle, and you'd be knowing or wanting to find angles and sides. So the way you'll typically begin is you'll look at the angle you know, the angle other than the right angle. So my acute angle is 27 degrees, I know that, and I need to take stock as to what sides we are given information about or want to find. Straight across from this is the opposite side. The 14 is the hypotenuse, and the side I want to find is the adjacent. So of those 3, the adjacent and the hypotenuse are noteworthy because we know something about them or we want to find them. So adjacent and hypotenuse relates to the cosine ratio from Sohcahtoa, and from that I can build an equation that I can solve. The cosine ratio, starting from 27 degrees, so the angle always goes right after the sine, cosine, or tangent, is equal to, well, the cosine ratio we know is the adjacent side divided by the hypotenuse, which in this case is the missing length divided by 14. In other words, the missing side divided by 14 must equal the cosine 27 ratio. Well, the cosine 27 ratio, if I hop over to my calculator, is 0.89. So 0.89, with all its numbers, must be what the missing side divided by 14 comes out to be. Now instead of working with 0.89, I'm going to work with the cosine 27 expression, because that way I can keep my calculations as accurate as possible right to the end and not have to worry about dragging along all these decimal points with 0.89. So I have cosine 27 degrees is x over 14, and this is an equation involving fractions. So to clear my fractions, I can multiply both sides of this equation by 14, which crosses the 14 off on this side. In other words, x is 14 multiplied by the cosine of 27. And on my calculator, 14 times cosine 27, and rounding that off is 12.47 centimeters. In our second example, the angle we are given is 38 degrees. And if we look at the sides in relation to that, we see that across from it is 8, which would be the opposite side. And the side we want to find over here is adjacent, because the hypotenuse would be the other side that has nothing up against it. And we are dealing with opposite and adjacent. So we can write an equation, opposite and adjacent, as tangent of what angle? Because the angle always goes here. 38 degrees is where we're looking from, and that's equal to the opposite divided by the adjacent side, which in this case is 8 centimeters divided by x. So tangent 38, remember that represents some ratio that the calculator could tell me must be 8 divided by x. That is what 8 divided by x must work out to be. So I want to solve my equation for x. I can multiply both sides of the equation by x, which will cross it off to the bottom. Let's cross reduce. And so 8 is equal to x multiplied by tangent 38. To get x by itself, we can divide both sides by tangent 38. And so x would equal whatever 8 divided by tangent 38 is. 8 divided by tangent 38 is approximately 10.24 centimeters. And for our final example, we will look at a situation of finding the angle. In the question here, we would like to calculate angle A. And so what sides do we know from angle A? We know a side straight across, so we know an opposite side, and we know this length here, which is the hypotenuse. And since we know opposite and hypotenuse, we will be looking at the sine ratio. So the sine of what angle? Well, in this case we don't know the angle, so we will simply place the variable for that. Angle A is opposite divided by hypotenuse, which is 12 divided by 19. So the sine of angle A has a ratio of 12 over 19. So this is one of those situations where we need to go in reverse. We know the ratio, we want to find the angle. So to go in reverse, we will enter the inverse sine of the ratio. Inverse sine of 12 divided by 19 gives us an angle of 39.17 degrees.